Welcome to Radiography Professor Explains. My name is Dr. Delia Lofton, and in this video, we're going to break down 4 important concepts in digital radiography: histogram analysis, values of interest, or VOI, automatic rescaling, and the lookup table, or LUT. These processes happen quickly after an exposure, but understanding what the computer is doing behind the scenes will help you understand digital image processing and recognize why an image can look acceptable even when the exposure was not optimal. Let's start with the histogram. After the X-ray exposure reaches the digital image receptor, the detector converts the X-ray energy into an electrical analog signal. The strength of this signal corresponds to the amount of radiation detected. The analog signal is then sent to an analog to digital converter, or ADC, where it is sampled and quantized into numerical digital values. The computer then performs histogram analysis, evaluating the digital pixel values that make up the image. A histogram is a graphical representation of the distribution and frequency of those pixel values, reflecting the range of receptor exposures recorded during image acquisition. Think of it as the computer taking an inventory of the exposure information captured by the detector. The horizontal axis represents the range of pixel or exposure values. The vertical axis represents how frequently those values occur. The shape of the histogram depends on the anatomy being imaged and the range of exposures reaching the detector. But the computer needs to know what type of image it is processing. That is why correct exam selection is important. When you select a chest, abdomen, hand, or another examination, the system has a reference histogram representing the expected exposure pattern for that examination. The acquired histogram is analyzed in relation to that expected pattern. The acquired histogram represents the distribution of pixel values generated from the radiation exposure received by the digital image receptor. However, not every pixel value captured by the detector represents useful anatomy. During this analysis, the system identifies the range of pixel values that contains the diagnostically relevant information. This range is known as the values of interest, or VOI. The VOI represents the range of pixel values that the computer identifies as relevant to the diagnostic image. For example, the detector may also receive direct radiation outside the patient or exposure near the collimation borders. The computer attempts to distinguish these values from the values representing the anatomy of interest. The useful range may be identified by a minimum and maximum value, sometimes referred to as VOI minimum and VOI maximum. The histogram contains the acquired pixel value information. The VOI identifies the range that should be used to process the diagnostic image. If the system incorrectly identifies the exposure field or the VOI, a histogram analysis error can occur. Histogram analysis errors can occur because of incorrect exam selection, poor collimation, positioning or centering errors, and unexpected objects such as metal. These factors can alter the distribution of pixel values or interfere with recognition of the appropriate VOI. Once the system has identified the relevant pixel values, automatic rescaling can occur. Automatic rescaling adjusts the useful pixel values identified during histogram analysis and maps them to an appropriate range for image display. This allows digital radiography systems to maintain relatively consistent image brightness across a range of receptor exposures, contributing to the system's wide exposure latitude. Suppose 2 images of the same anatomy receive different receptor exposures. Without processing, their appearance could be very different. Automatic rescaling allows the system to adjust the pixel values so both images can be displayed with relatively and appropriate brightness. But here's the important point. Automatic rescaling does not mean the exposure was correct. An overexposed digital image may still look acceptable because the system has adjusted its display. This can potentially contribute to dose creep if the radiographer evaluates exposure based only on image appearance. That is why the radiographer must evaluate the exposure indicator to determine whether the appropriate amount of radiation reached the image receptor, rather than relying solely on image appearance. Once the image data have been analyzed and rescaled, the lookup table, or LUT, determines how those processed pixel values are displayed as specific shades of gray. In simple terms, the LUT tells the computer, for this pixel value, display this shade of gray. Different anatomical examinations require different grayscale characteristics. A chest radiograph, for example, has different processing and display requirements than an extremity. This is another reason selecting the correct examination from the workstation menu is important. The selected exam helps determine which processing algorithm and LUT will be applied. Now let's connect everything. The X-ray exposure reaches the digital detector and produces pixel data. The system analyzes the histogram. The values of interest are identified. The relevant values undergo automatic rescaling. The lookup table determines the shades of gray. And finally, we see the processed digital image. Here's the easiest way to remember the process. Histogram analyzes, VOI selects, rescaling adjusts, and the LUT displays. Digital processing can make an image look properly exposed even when receptor exposure was not optimal. Always evaluate the exposure indicator along with image quality. Understanding what happens between the detector and the displayed image is essential to understanding digital radiography. Please like, subscribe, and follow Radiography Professor Explains for more radiography concepts made simple. Thanks for watching.